All right, guys, here is the 2019 release test. You're going to remember a lot of these initial problems. These were the review problems that I put on your Chapter 7 test that you had last week. So you might have done some corrections and already done these problems. If so, move on ahead. The first one, if we're taking the integral of x squared over 4, you could think of that as 1/4 x squared. And when we take that antiderivative, we are going to add 1 to my exponent, divide by my new exponent, but I had the constant of 1/4 already out front, leaving me with x cubed over 12 plus c. And what that means is the derivative of this would equal what I started with. So I feel good about it. The answer is B. We're moving on. On number 2, if it says write the equation of a tangent line, I personally would start with point slope form. Y minus y1 equals mx minus x1. And so let's go ahead and find my m. My slope would be the first derivative. So the derivative of cosine is negative sine of x. They want the derivative at pi over 2, which is negative sine at pi over 2. If you think about the unit circle, pi over 2 is up here, and that is the point 0, 1. So the sign there is 1, and they said negative sign, so we got a slope of negative 1. So when I go to look at my answers, my slope has to be a negative 1, so I'm going to cross out A and B. What'd I just do? Those are gone. All right, the last thing that we need if we were going to go to put this in point slope form is we need y minus my y coordinate. Well, what's going to be my y coordinate if my x is pi over 2? I'm going to plug in pi over 2 for my x, and my y would equal the cosine of pi over 2. Just like we reminded, the cosine of pi over 2 is the x value at pi over 2, and that is 0. So when I go to write my point slope form, we'd have y minus 0 equals my slope, which we already found was negative 1, times x minus my x coordinate. Y minus 0 cancels out to just y, and if I were to distribute my negative 1 slope, I'd have a negative x plus a pi over 2, and that is answer C. Let's keep it going. On number 3, what we see here is a lot of chain rule. We've got a lot of layers. Remember the peanut M&M that we had? We've got a lot of layers. So we've got an outer layer. We've got an outer layer of a 2 exponent, an inner layer of a sine of root x, and another inner layer of that root x. So when I apply the chain rule, because it asks us to take the derivative means take that exponent out front, so I'd get 4, leave the inner function, take the exponent down by 1, times the derivative of the inner function, but this is another chain rule. On this one, I've got to take the derivative of sine, leave the root x. So I've got the derivative of sine is cosine, leave the root x, which you could think about it as x to the 1/2 if it would help you, because our next step is we got to take the derivative of my angle, which is x to the 1/2. The derivative of x to the 1/2 would be 1/2 x to the negative 1/2. That's going to leave me with 4 times a half, leaving me with a 2. I've got a x to the negative 1/2 that I'm going to need to bring down and have it as x to the 1/2 on the bottom, which is the same as root x. And I still have a sine of root x and a cosine of root x in the numerator. And that to me looks like D. Okay. A lot of people, oh, this one was already on your test. Okay, if you haven't done your corrections or you're wondering again, this function is too complicated for us to take an antiderivative following just antiderivative rules of adding 1 to the exponent and taking 1 away. So we're going to go ahead and use u sub. So when you pick your u, you want to pick something whose derivative is going to be helpful. So I'm going to make my u x cubed plus 3x minus 5. Therefore, the derivative of u is 3x squared plus 3. I'm going to separate my variables, and I get 3x squared plus 3 dx. And when I look at my function, I don't need 3x squared plus 3 dx, but I need 1x squared plus 1 dx. So I'm going to go ahead and divide everything through by a 3, and that would leave me with 1/3 du equals x squared plus 1 dx. And that is very helpful because I see that right there. So when I go to rewrite my integral in terms that I can integrate, I'm going to say I've got 1/3 du, and that takes care of this and this. Then I've got the quantity of u to the third left. So I've got 1/u to the third left. I can take this antiderivative easily by thinking of that as u to the negative third. And when I go to take that antiderivative, I'm going to leave my constant. I don't know why I made it a negative, but we've got a 1/3. I'm going to add 1 to my exponent. That brings it to -2. Dividing by a -2 would leave me with -1/6, and I'm going to bring my u down squared. When I replace my u back in, I'd have -1/6. My u was x cubed plus 3x minus 5, and I've got to square it. Always remember our plus c, and this answer is D. How many of us have forgotten about concavity and how to figure out when my function is concave up or concave down? Well, here's the reminder for you. Concavity is always the second derivative. So I'm going to go find my first derivative, which is 12x squared minus 4x cubed. I'm going to go find my second derivative, which is 24x minus 12x squared. In order to find where something's concave up and down, we need to see when the second derivative equals 0 or is undefined. This function is not going to be undefined because we're never dividing by x. So let's go find out when it's equal to 0. I'm going to factor out a 12x, leaving me a 2 minus x left. When are each of these quantities going to equal 0? When would 12x equal 0? When would 2 minus x equal 0? And our critical numbers would be 0 and 2. And what that means is we're going to go make a sign chart with 0 and 2. Those are x values. We're going to plug them into our second derivative, and that's going to tell us what our function is doing. I'm going to plug in numbers less than 0, between 0 and 2, and bigger than 2, knowing that these, again, are my critical numbers. When I plug in a -1 to my second derivative already factored, we got to think about, is that quantity going to be positive or negative? Well, a -1 times 12 would get me a negative here. 2 minus -1 would get me a positive. So I've got a negative second derivative. And if my second derivative is negative, my function is concave down. When I go to plug in a 1 to my second derivative, 12 times 1 is 12. 2 minus 1 is 1. And I would be left with a positive value. If my second derivative is positive, my function is concave up. And 5, if I were to plug in my 5 to my second derivative, I'm left with a 2 minus 5, which is negative, times a positive, would make my second derivative negative. Again, if my second derivative is negative, my function is concave down. They asked, where is my function concave up? So that will be this area from 0 to 2. Answer C. Okay, if we continue on, number 6, when they ask for the derivative, we're going to say, all right, the derivative of x with respect to x is 1 dx dx. The derivative of 3y to the 1/3 would be 1y to the -2/3 times the derivative of y with respect to x, that is dy dx. And this is implicit differentiation that we're reminding ourselves about. Again, if that's equal to the derivative of y, which is 1 dy dx again. Very hard to remember those. They're asking about what is dy dx. So I've got to get all my dy dx's on the same side. So I went ahead and I subtracted y to the -2/3 dy dx. And they said, what is dy dx? So I'm going to go ahead and factor that dy dx out. And I'd be left with a 1 minus y to the -2/3. And then I could divide through and I'd say, all right, my dy dx is 1 over 1 minus y to the -2/3. That's my dy dx. And they said, great, now evaluate that at the point 2, 8. Well, I don't have any x values, so I do need to plug in my 8 to my y value, to my y coordinate here. So I'm going to say, all right, actually I'm going to go up here. This one's a little algebra heavy. We've got 1 over 1 minus 8 to the -2/3 is my dy dx. If you're struggling with that negative exponent, don't forget that just means that we've got 1 over 8 to the positive 2/3. When you bring something down, the exponent becomes positive. And again, you do not need to do 8 squared first. You could do the cube root of 8 if you want. The cube root of 8 is 2. 2 squared is 4. So I'm left with 1 over 1 minus 1/4. 1 minus 1/4 is 3/4. 1 divided by 3/4 is the same as 1 times 4/3. And 1 times 4/3 is 4/3. All right, on number 7, they're asking us to take the derivative. The derivative of x to the 5th is 5x to the 4th. So right off the bat, I can take off a because they did the antiderivative or the integral. Now, you are going to want a little reminder of how to take the antiderivative of negative 5x. Picture that as e to the x. And what's the derivative of e to the x? It is e to the x. But something that we've forgotten is that it's also times the natural log of e, or natural log of the base. The reason we're allowed to forget that is because we all know the natural log of e is 1. So I would just be left with e to the x. But when my base is not e, we can't forget that step. So the derivative of negative 5 to the x follows the e rule, and it will be minus 5 to the x times the natural log of the base, and in this case, it's the natural log of 5. So when I see that, that makes D the answer. Everyone, we are going to go ahead and skip 8 because that is a topic that we haven't covered yet. That's L'Hopital's rule. We are going to skip 9, that's area, that is 8-2. And let's get to 10. Again, you might recognize this from your test. If it says find the derivative of g, and g involves division, we need to go ahead and do the quotient rule. And the quotient rule, again, one more time, is low d high minus high d low, all over low. And in this case, that would be g prime. This is ugly. In this case, g prime of x would be low f of x times the derivative of the higher, which is 2x, minus high d low, all over low, low. Be mindful of your parentheses. They want g prime at 2. So I'm going to go ahead and plug in 2's to my entire function. F of 2, 2 times 2 is 4, minus 2 squared plus 1 is 5, times f prime of 2, all over f of 2 squared. All right, f of 2. This is a graph of f. So f of 2 is the y-coordinate, which is 3. So f of 2 is 3 times 4 minus 5 times f prime of 2. F prime of 2 is saying what's the slope of f when x is 2. This is a nice linear function, so when I talk about slope, I'm looking for what is the rise over run at 2. You could pick that up at any point, wherever you can see a good coordinate cross. So I'd say, all right, at 2, that's perfect, and I'm going to rise 1, 2, 3, 4 over 1. So again, my slope, 1, 2, 3, 4 over 1. My slope is 4 when x is 2. All over f of 2 squared. Oh no, we already knew that we had to put it over f of 2 squared. So f of 2 in this case, again, is 3. We square it, we get 9. This is multiple choice, so we've got to work it out. We got a 12 minus a 20 over 9. 12 minus 20 is negative 8/9. Bada bing, bada boom. And finally, this was the bonus question that I said if you were to simplify, then we'd be able to take an antiderivative quite nicely. So if I were to look at this initially, I don't know what the antiderivative of x squared minus x over x is. But I do notice that there's an extra x up top that then would factor out with my x on the bottom, and I'm left with the integral of x minus 1. And we know how to take that antiderivative. We'd add 1 to my exponent, divide by my new exponent, and the antiderivative of negative 1 is negative x, because the derivative of negative x is negative 1. We're going to evaluate that from negative 1 to 1. Be careful with your algebra here. I'm going to plug in my upper bound, minus parentheses, plugging in my lower bound, negative 1, squaring it, minus negative 1. So I'd be left with 1/2 minus 1, which is -1/2 minus 1/2 plus 1. That leaves me with -1/2 minus 1/2 plus 1 would be 3/2, leaving me with -1/2 minus 3/2 would be -4/2, or -2.